All right, let's continue with that area stuff that we were doing yesterday. We did area and perimeter. What's the difference between area and surface area? Well, I'll tell you. Glad you asked, though. Surface area is if you're talking about the area of a three-dimensional object. Okay, so if I had a box up here, I don't know, usually I have a box somewhere in reaching distance, but I don't now. But anyway, let's pretend we had a box up here, and I want to find the area of all the surfaces to that box. That's the surface area. Okay, so let's talk about that. Let's draw a box. Yeah, let's just draw a rectangular box. I'm not very good at drawing stuff three-dimensional, so just bear with me. I might, with this program though, might make it a little easier. So let's see if I can. So yeah, we'll do that. I'm just going to copy and paste these. Put that there. So this might work out pretty good. Yeah, look at that. That's way easier than drawing by hand. You guys paying attention to me? Okay, why are you guys having your own conversations? Tim, Rihanna. All right, so let's talk about it. This is a two-dimensional surface. We're trying to draw something three-dimensional on it, so you got to use your imagination just a little bit. Okay, this is basically, here, look, I'll use this box right here. Oh, come on. There we go. All right. This box right here, that's kind of what it is. All right, see this surface right here? That's the front of it. And then see this side over here? That would be what? This side right here. It's kind of like tilted like that. Yeah, everybody see that? So you got to use your imagination a little bit. And then you got the top. All right, so you've got the top as well. But there is another side to this, isn't there? It's just back here, right? You don't see it. From where you're looking, you don't see the back, but you know it's there. Would you agree? All right, so a lot of times they'll put like dotted lines here, but then I get real confused when I start drawing the dotted lines. It looks a mess, but just use your imagination. So you've got the top, and you also have what? The bottom, right? Now tell me something about the area of the top and the bottom. They're the same, right? Okay, because this rectangle, the top, is the same as this rectangle, the bottom. Everybody got that? All right, then you got the front, and then you got the what? What are we going to call that? The back. So this one is the front. And then I'll point an arrow. You know what that is? It's not pointing to the top. It's pointing to the what? To the back. All right. And then you got these sides. Okay, so again, on this box, this would be a side. This would be another side. So we've got a right side. And then we have a what? A left side.
This is a rectangle, right?
Yes, it's a rectangle. Everybody got that? All right, so you got all those surfaces. So that's what you want to find the surface area of. And that's what they're going to ask you. They say, find the surface area of this. Now, they don't really give an example for this, but we'll make up our own examples, all right? So let's say the up and down length was, I don't know, 3. Is that all right? And let's say it goes back, I don't know, let's say it goes back 4. And then across the bottom and across the top, doesn't matter which one, let's say it's, I don't know, 8. It looks like it could possibly be twice as big as that. I don't know. We're just making things up. Everybody watching? Everybody paying attention? All right. So I want to find the surface area of this whole thing. Surface area. So I'm finding more than just one area. Now they're rectangles, which makes it pretty easy. What's the formula? Again, this is one of our formulas we have to know. What's the formula for the area of a rectangle? Length times width, exactly right. So let's just do the front right now. So we've got, let's start listing them. Surface areas. So let's do the front and the what? And the back, because they're exactly the same. The front and the back are exactly the same shape. All right, so if I find the front, I just add it again, and I got the front and the back. Yes? All right, so how do I find the area of the front. Let's just do the front right there. What is it? Give me numbers that I'm multiplying together. Don't 3 times 8, right? So I've got 3 times 8. That's the length and the width, right? Doesn't matter which one you call what, but this is one side of the front. This is another side of the front. 3 times 8 is 24. Now that's just the front. What do I got to do to find the front and the back? Just add it again, right? So this one's the front, this one's the back. So what is that altogether? 48. Is that the surface area of that whole entire box? No. Just the front and the back. Okay, just those two, the front and the back. It's it. What else do we have to find the area of? Kind of running out of room here. The sides, is that what you want? Yeah. Okay. All right, so let's do the sides. Let's do the left side and right side. We'll put left and, nope, I've already started writing this down. So let's do the left and right side. So that would be this. Now look, I don't know what any of those lengths are, or do I? Sure I do, all right? Because this would be 4, that would be 4, correct? This up and down would be 3, this up and down would be 3. So how do I find the area of that right there? 3 times 4, correct? Which is 12. Now that's the right side. What's the other side going to be? It's also going to be 12. So I just add the 12 and I get what? 24. So far, what do I have? I got 48 for the front and the back. I got 24 for the left and the right side. What's the only thing I'm missing now? The top and the bottom. So let's just put it right here. Top and bottom. So let's find the area of the top and the bottom. Let's do the top. All right, I'll tell you what, I'll shade it in just ever so slightly. So this is what we're trying to find right here. So what two sides make up the top? This top. Well, this side does, right? So that's a 4. What about this length right here or this length right there? What's that? What's number?
8.
It's 8. Okay, so that, why is that 8? Because this is 8. Look. That length is 8, that length is 8, that length is 8. Everybody see that? So if you want to find the shaded part, the top, one side is 4, the other side is 8. So what do? 4 times 8. 8 fours are 32. That's the top. What's the bottom going to be? It's going to be 32 as well. And then you add those up and you get 64. Are we done? Do we just circle those 3? No. What do we have to do to them? That's right. So I'll call it the total surface area. Now let's move that. Right here. Equals. All right. Front and the back came out to be what? 48. Top and the bottom came out to be 64. And the left and right side came out to be 24. What do I do with all those? Add them all up. All right. Probably could do that in my head, but I'm going to stick it in a calculator. So 48 plus 64 plus 24 is 136. 136. All right, and there you go. One thing I didn't talk about yesterday were our units. Okay, our units are really important. So let's say we measured this in inches. So that was 3 inches, this was 8 inches, and this was 4 inches. Okay? Now watch very carefully. 3, remember I did that 3 times 8? Technically it's this. It's 3 inches times what? 8 inches. Well, 3 times 8 is 24. But what else do I have to multiply? The inches. Okay, what's inches times inches? What's anything times itself? It's squared, right? So this would be inches squared. So every one of these is inches squared, and inches squared. So when I add up all those inches squared, what do I have? 136 what? Inches squared. And that's very important. Because 136 inches squared is a lot different than 136 miles squared. Would you agree? All right, so the units make a huge difference in what you're trying to do. And there you go. It really wasn't much different than just finding the area of one rectangle, except you had to find the area of how many? 1, 2, 3, 4, 5, 6 different rectangles. Okay? So you had to find the area of 6 rectangles and then add them all up, and then that's what you get. So that's what they're asking for when they say find the total surface area. And you should be able to look at it. A rectangle box is fairly easy, right? Top, bottom, front, back, left, and right. And then you just got to figure out what lengths are each of those sides of the rectangles. All right, enough of that. I think we took enough time on that. They give you a formula for this. I don't really care for the formula. I think that's more confusing. I think what I did right here is just looking at it and finding the individual areas of all the sides. I think that's the easiest way of doing it. I will show you it just in case you want to know. Like you could call this length and width, right? Let's call that the length. Let's call that the width. What would we call that one? Maybe the height, okay? All right, so how did we find the front? We found the length times the width, correct? But you got a front and a back. So what'd you do to that length times width? Multiplied it by 2. Okay, what about the side right here? You've got a height and you've got a width. So how did I find the area of one of the sides? Height times width, but if you do both of the sides, it's what? It's twice the height and the width. All right, what about the top and bottom?
Wait, what's height and width?
Would be the sides, right? Right? This height and this width make up that side, that left side, right? Multiplied by 2 because there's a left and a right side. That's why we multiplied by 2. What else didn't we do? We didn't do the top and bottom, did we?
No.
So what's the top and bottom going to be? Well, that's the height, and this is the length. So what's the top going to be?
Height times width.
It's going to be height times the length, but there's a bottom to it as well, so what do? Multiply it by 2. So here's the formula. Again, this is why I don't really care for this formula. To me, I'm just going to look at it, figure out all the sides, right? Multiply them together and find the rectangles and add them all up. But anyway, here it is. So the total surface area, I'll put SA for surface area. What's this one? 2LW. And then this one is what? 2HW. And then there is, where did I write the other one? Right here. And then that one would be what? 2HL. So you could put that into your formula, right? All these numbers into that formula and then work it all out. I mean, that's okay. I guess it's nice to have a little formula. There's your formula. But you don't really have to know that exact formula, all right? All right. So now, let's talk about volume for a minute. And we're going to use that same rectangle. Tell you what, since I can do this, let me get rid of this, just so I don't have to redraw that rectangle again. You got all that down, don't you? Tell you what, let me just get rid of, oh, I know I did that. Hold on. There we go. It might have been quicker just redrawing the rectangle. I don't know. Oh, what happened there? I do that once in a while, and I have no idea why it does that. It's so weird. Get rid of that. Get rid of all this stuff. This stuff. Oh, I should have just started from scratch. Well, it's too late now. Let's get rid of all of this. All right, get rid of all of that. All right. Oh, that was a dumb move. And might as well. Get rid of this as well, huh? All right. So now what we're going to do is we're going to talk about the volume. The volume. Do you remember when we first did the area yesterday? We said we broke that up into a bunch of squares. We said how many squares can fit on that rectangle. But now what we're going to do, everybody up here, I see tops of heads. I need to see eyeballs. Everybody's eyeballs up here. I haven't written anything down yet. You shouldn't be writing anything down. I still see people writing. Okay. We'll do this in a second. All right. Do you remember when we found the area of a rectangle? We split it up into a whole bunch of squares, and we said the area is how many squares. That's why it's square inches, right? Yes? From yesterday? It was just yesterday. All right. This time what we're going to do is we're going to talk about something called volume. Now, we're not talking about how many squares can fit on the front of it. We're talking about how many cubes can fit inside of it, right? So if I had a little 1 by 1 by 1 cube, right, three-dimensional, and I could stick them in here, how many would fill up that whole entire box? So if I had this box and I was able to cut out a 1 inch by 1 inch by 1 inch cube and stick it in here, how many of those cubes could fill up this box? That's finding the volume. Everybody hear that? Yes? Okay. That's the volume. That's different than area. Area is just how many squares can you fit inside of that rectangle. Volume is how much stuff you can fit inside of it, inside the three-dimensional object. Yes? All right. A lot of times when you fill stuff up with liquids, you talk about how much volume can it hold. Like a gallon is a measurement of volume. A liter is a measurement of volume. How much stuff can you put inside of a three-dimensional object? Okay? That's volume. Make sense? So let's do this. It's a very simple formula, all right, which is really nice. So volume of a rectangular box, okay, is this. It's the length times the width times the height. And that's it. You multiply all three of those together and you got the volume. That's way easier than finding the surface area of the thing. All right, so it's the length times, I'll put it x for times, the width times the height. And that is something that you need to memorize. And it's not that hard. You just take the three different measurements, right? Those are your only three different ones. Because look at this line right here. What's that line right here? That's the length, isn't it? What about this one right here? That's the length. This is the h. What is this one? That's the h. This is the h. See, you follow me? These are the only three different ones. The length, the width, and the height. Just multiply them all together and you got the volume. Super, super easy. All right, now the next one, I just cannot draw at all. All right, so, but it's, I'll just tell you what it is. It's a sphere. All right, I think I actually, hold on, let me just check. I think I might have a picture of a sphere somewhere. Let me see. Geometry, shapes. Ah, look at that. Isn't that good? Boom, there it is. See, that was nice. All right, so that right there is considered a sphere. Yes. Go ahead. So this is a sphere. It's like a ball, all right? Think of it as basketball, soccer ball, without all the little curvy things on, on it. You know, soccer ball's got these little panels and stuff. But a nice smooth ball. That's a sphere. All right. Now, watch the equation for this. Now, there is a way to explain where they come up with this equation. I'm not going to do that. I'm just going to give it to you, okay? Because you won't be interested. You're not interested in anything I say anyway, so you definitely won't be interested in that. So here's the volume of a sphere. It's a ball. How much stuff, how many little cubes can you fit inside of that ball? That's what you're finding when you find the volume of something. All right, so here it is. It's a little bit more confusing, but it's not really that long. First of all, you start off with a weird number, and you're like, how in the world do they get that? Well, don't worry about it. I hate to say that because whenever I teach this, if I teach this to like an honors geometry class or something like that, I would usually go through an explanation on why these numbers are the way they are. But I'm not going to because I don't think it makes any difference. All right, so it's 4/3, 4/3, and then it's a pi, and then only one more little thing, r². By the way, when you find the volume of something, what if I said the length was, I'll make it super easy. The length was 2, the width was 3, and the height was 4, okay? What would the volume of a rectangular box be with that? It's 2, what? Inches, right? Times what? 3 inches times what? 4 inches, which gives you 2 times 3 is 6. 6 times 4 is 24. What are my inches? Is it inches squared this time? There's 3 of them. So inches times inches times inches is inches cubed. So that tells you that's how many cubes you can fit inside of it. You can fit 24 cubes inside of that box if those are my dimensions. You with me? So this is also going to be cubed. That's one way it's easy to remember, at least that you have a cubed in here. All right, so the sphere is r cubed because the 4/3 doesn't have any units, right? It doesn't have inches or feet or miles or anything. Pi doesn't. It's just a number. What's the only thing that has any units on this? The radius. All right, so here's the radius right here. You would cube the radius, then you multiply it by pi, and then multiply it by 4/3. Here's another way you could write it. If you don't like the 4/3, a lot of times we write it like this. 4 pi r cubed over 3. Depends on which one you like. This one, if you're actually putting numbers into it and putting it into a calculator, and I would use a calculator for this, especially when you get pi, all right? So I would use a calculator. But you still got to know how to put the numbers in the calculator. It's not that easy sometimes. So you got to make sure you do that correctly. By the way, when you use pi right there, use 3.14. Don't use the calculator number, just so we're consistent, all right? Because some people's calculators go out a certain number of places. Some other calculators go out a little bit further or not as much. So let's just be consistent and say 3.14 when you use pi. Does that make sense? So what are they going to give you? All they're going to give you is one thing, and they're going to give you the radius. Let's make it as easy as we can. Let's say the radius is 2 feet. We'll go feet this time instead of inches, okay? So what if it was 2 feet? Then how would I find the volume of this sphere? Well, let's plug them in. Volume equals what? 4 times what? What's pi? 3.14, thank you. A little hesitation there. What's the r?
2.
It's 2. It's 2. But it's 2 what? Feet. But what are we doing to that radius? We're cubing it. So we put a cubed here over what? 3. And now it's just calculator work. See, it's just plugging stuff in. It's not really hard to do, is it? Right? You just plug stuff in, right? But then you got to know how to do it on the calculator. Well, I happen to have a calculator on my computer. If you're watching this on YouTube, you won't be able to see this. But here we go. Here's how I would do it. Ready? I would go 4 times 3.14 times, now we can do this part in our head, can't we? 2 cubed.
Without a doubt, it's going to be 8.
It's going to be 8. 2 times 2 times 2, right? 2 times 2 is 4, times 2 is 8. So I can just do that in my head. So 8. And then you take that whole thing and you divide it by 3. I think it's going to divide the whole thing by 3. I don't know.
Might not. Might be 8.
Let's see. So I just made up that number. Is that what you got?
I would
Let's do it like this. Watch.
All of it, solve it, then divide that
Let me see. What am I doing? Oh, I'm putting all these. I'm doing all these keyboard shortcuts. And there we go. All right, let's do this. Let's put parentheses. I want to see if we get the same thing. I'm just curious. I just don't know. So I'm going to start with the parentheses and then do the same thing. 4 times 3.14 times 8. Close the parentheses and then divide that by 3. Let's see if we get the same thing. Yeah, it's the same thing. So it did what I thought it would do. All right. All right, so that's how you put it into a calculator. Now, I would absolutely have a calculator on you when we're going to take a quiz or a test on this. All right, I wouldn't want to do all that stuff by hand, would you? No. Okay, so we'll just keep it like that. Let's do another one. Here we go. All right, let's talk about this thing. Anybody know what that thing's called? What is it? What'd you say? I can't hear. A cylinder. Very good. Is that what you said? Good. All right, that's called a cylinder. It's actually, listen, I'll be a little bit more specific. It's not just any old cylinder. It's a right circular cylinder. Circular because the bottom is a circle and the top and the bottom, see how they're perpendicular right here? Okay, so it's a right circular cylinder. And we have a volume for that.
This is hard to draw, honestly.
I know, that's why I copied and pasted it.
I can't copy.
So let's find the volume. Here it goes. You ready? It's pi again. Because you're dealing with circles. Anytime you deal with circles and you're doing area or circumference or volume, you're always going to have pi in it when you're dealing with circles. Everybody hear that, what I said? So it's going to be pi, then it's going to be r squared, and then it's going to be times h. There it is. I'm not going to explain where that came from. It's actually not hard where it comes from because what is the area of a circle? What's the area of a circle?
2 pi r.
No, circumference.
It's pi r squared.
Pi r squared. Now watch. So look, watch this. Shh. Okay, stop the fooling around. Okay, it's not that funny. It's really not that funny. You think you're the comic, but you're really not. Okay, you're the unfunny comic. All right. So just pay attention to me. All right. You're just so wrapped up. Your whole life in my class is you're worried about making people laugh. That's all you want to do in here. I don't care. All right, so just be a student. Don't be a comedian because it's not funny. I've had funny students. I had this one kid and we kind of bonded a little bit and I took him to, forget it.
I'm listening.
No, you're not. Every time I say something, you have a comment, so forget it. No, I'm not going to tell my story. All right, so watch. The area of this the area of that circle would just be pi r squared. But if you go up 1 and 2 and 3 and 4 and 5 or whatever, however high you go up, right, you're going to multiply that pi r squared by how high you go up. That's your height, okay, from here to here. So the bottom is pi r squared. That's the area of the circle. The h is just how high you go up. All right, so that's the only difference in the area of the circle and the volume of that cylinder. You just multiply it by h. So it's kind of an easy formula to remember. The volume of a sphere is probably the hardest one. The one we just did, the 4/3, that one's probably the hardest one to remember. This one shouldn't be that hard to remember. You think of a cylinder as a circle, how high up you go. All right, there's the area of the circle, and that's how high up it goes. All right, that's how you can remember it. Pretty easy. So if they tell you the radius, they tell you the height, plug them in. That's not that big of a deal. All right, I got one more thing before we quit. What they're going to do on some of these is they are going to do a combination of a couple shapes. So let me go back to white. So let's go like this. I'm going to copy and paste that. Then I'm going to transform it. Let's see, what do I want to do? I want to flip it. How do I flip it? Oh, there we go. Flip horizontally. Yep, that's what I wanted. All right, looks like a V. Now, I don't think I'm going to be able to, yeah, I could draw a circle, but then I'll just try to. Oops, I reached the edge of my tablet. Let's try this again, a little lower. Kind of looks like an ice cream cone. Oh man, I missed it. Anyway, that's like half a circle. Okay? I can't really draw half a circle on my computer program, but that's half a circle. Everybody got that? Okay. So, if I want to find the surface area of this, find the surface area. I'll give you some numbers and stuff, because you can't find anything yet, because you have no idea any of these numbers. So what they do tell you is this. They put a dotted line right here, and they say that that is 6, and it's 6 centimeters. And they also tell you that dotted line, the one that's going across, that's 4 centimeters. Everybody see that? So that 4 goes from here all the way to here. The 6 goes from here all the way down to the bottom. What I want to do is find the whole surface area of this. So I got 2 different shapes. What's the one shape that I have that's pretty easy to see? The triangle. Very good. Okay, I've got this one here and here. Everybody see the triangle? So let's write it down. I got a triangle. How do I find the area of a triangle? Do you remember what it is? Again, this is something you got to memorize. Did it yesterday. Look at your notes if you have to.
1/2 base times.
That's not us, is it? All right, let's just do this real quick. All right. So watch. What's the area of a triangle? 1/2 the base times the height. So let's do this triangle right here. So it's 1/2. What's the base of this triangle? No. It's 4. Okay. And what's the height of the triangle? Remember, they have to be perpendicular, the base and the height. So this would be 6. 4 times 6 is 24. What's half of 24? That's 12. So the area of that triangle is 24. What's this curvy thing right here? It looks kind of ugly, but what's the ice cream part of this? This is half of a what? Half of a circle. So how do we find the area of a circle? Pi what? R squared. What's the radius of this? It's 2. All right, see the whole thing is 4, but the radius is 2. So it's pi times 2 squared, but it's not a whole circle. What is it? Half of a circle. So what do I do with this? Divided by 2. So 2 squared is 4. 4 divided by 2 is 2. So it's 2 pi. Now, what do we do with this? What do I do with this and this? I found the triangle. I found this. I add them up. So you can do that, and you're on your own. Okay? So finish up that homework from yesterday where it's got the volume and all that stuff. All right, so now you should be able to do all that homework that I assigned yesterday. So get that done, and we'll go over that tomorrow.